Hello everyone, and welcome to Intel 471's Happy Hunting series. This is the series where we look at attackers' behaviors, break down the logic, and provide you with a way to proactively hunt for it. I'm Lee Arcanel, and today we're discussing FileFix, a social engineering technique that was a direct evolution of the ClickFix campaigns. While ClickFix relied on deceiving users into using the Win+R keyboard shortcut, FileFix is a little more insidious. It leverages the inherent trust that users have in the Windows File Explorer address bar. By moving the execution vector from a system dialog to a file management interface, adversaries are successfully bypassing traditional mark of the web protections and user suspicions. In this incident, captured by the DFIR report, it started with Kongtuke, aka Land Update 808, who was an initial access broker and led to a new interlock rat variant. How did it get there? Let's check it out. So the adversaries injected a single line script into compromised legitimate websites. The JavaScript on the page employs heavy IP filtering so that it fires only on high value targets. The user is presented with a fake verification or CAPTCHA prompt, which is a critical technical shift in this attack. When the user clicks verify, it triggers the browser to call explorer.exe to open a select file window. Simultaneously, the malicious JavaScript writes a heavily obfuscated PowerShell command to the system clipboard. The user is then instructed to paste the verification code into the File Explorer address bar. Because explorer.exe interprets strings entered in the address bar, it treats the pasted command as a direct instruction to the operating system. Once the PowerShell one-liner is executed, that's when the payload makes it to the victim machine. But what can you do about it? Well, today we're using the browser spawning suspicious applications, potential exploit, or social engineering community hunt package from Intel 471's Hunter platform. Now, I know there's a lot thrown at you. There's artifacts, there's IOCs, but how are we going to break this down so that we can understand what we're looking for? It really does depend on the artifacts, so let's take a look. So what's key to this hunt package finding a true positive is that we've identified the parent processes being a browser. So in this case, we build the key value pair, or the field value relationship. You can see that in the first selection, this is our parent process selection. We define the parent process as Chrome, iExplore, Edge, and other browsers that may be used in your environment. Now, that's one thing. So that's the one part of the logic that we need. The second part is the suspicious child processes. Now, we define those down here under the process selection or child process selection. Here we have common command and scripting interpreters or living off the land binaries that adversaries have used or could use in their attacks while using the FileFix technique. You can see familiar faces like Windows Command Shell, PowerShell, and even Python. But by pairing these two together, saying looking for any of these parent processes, spawning any of these child processes, that's a good indicator that something malicious or suspicious is happening in your environment. But what does that look like in a tool, and what does the data look like? Well, let's take a look. So we have the base logic and we have our artifacts. What does that look like in a tool? Here we have our Splunk query all built out for us. We're using sysmon as our log source, which captures the fields and things that we need. So it's going to capture parent processes, it's going to capture child processes, and we use the tool to display it nicely for an easier read. So what we can tell from the data is that we have two instances where the parent process was a browser. In the first one, we can see msedge.exe, and the second one, a more suspicious chrome.exe executing from James Murphy's documents directory. So if you look at the child process on the left over here, we see that Microsoft Edge launched Windows Command Shell and Chrome launched PowerShell.exe. Now we also have command line arguments, which give us more insight into what the attacker may have been after. And you can see a couple things like this second one. Really, we see that it's a PowerShell encoded command that's executing, which gets a little suspicious. But that's the type of data and that is the type of artifacts that this query will help you identify in your environment. Now that you got the hunt package that's going to help you identify FileFix, just remember that it's a reminder that attackers don't need a brand new exploit to change the game. Sometimes all they need is shifting the user's trust to a different application or to another interface. By moving execution into the File Explorer's address bar, adversaries are taking advantage of behaviors that feel normal to the user, but it creates a very different picture for defenders. That's why threat hunting around process lineage and browsers spawning suspicious child processes really matter. As always, the goal isn't to just have the IOCs and find them or detect the payload. It's really to understand the behavior so you can identify when it's being used in your environment differently by different attackers. Thank you for tuning into this Happy Hunting episode. If you found it insightful, drop a comment, hit the like button, but I hope you stay tuned. Until next time, happy hunting.